So my name is Guillaume Bichot, and I work for Broadpeak. And I'm going to try to explain you what is multipath HTTP adaptive streaming. It's a technology that helps the content provider and the broadcasters to control their QE regarding their content delivery chain solution. I'm going to start maybe. No, I think it won't work like that. We need to solve that, right? I'm not going to talk with this. Well, maybe. So I'm going to start with explaining what is multipath HTTP adaptive streaming, and then I will depict a use case about how we can use this technology to enhance delivery solutions for content provider broadcasters. So let's start with HTTP adaptive streaming. So you probably know already well this technology, but let's refresh the memories because it's very important for the following. So we start with a stream that is encoding in several qualities. Here in this example, we have 3 different qualities. Each of the stream is split in a chunk or segments. Let's call it segments of equal duration. All segments start with a reference frame in such a way that you can start playing a segment from one quality, and for the next segment, you can switch to another quality. It will be seamless, right? You know perfectly that. On the terminal side, the system works like this. The player measures continuously the bandwidth, the available bandwidth, and we select the next segment according to the measured bandwidth, right? And it is almost seamless for the user. This is a good technology. It works over TCP, so it is TCP friendly, as you know. It is also friendly for crossing any kind of network. It's firewall friendly, I mean. And it adapts dynamically to the available bandwidth to the networks. But there is one drawback, which is the solution is prone to congestion, which means if you have failure, if you have buffer bloating, then you're going to experiment jitter, quality variations. So in order to compensate this, you need to buffer. And if you buffer, you add latency. So in order to solve these impairments, we have, in the past, worked on something called HTTP adaptive streaming, multipath HTTP adaptive streaming, and this is what I'm going to present now. Let's go directly with the technology. It's very simple to understand. Instead of having only one path to deliver the content, we're going to operate several paths concurrently. So regarding the previous example, here we have 3 servers. Each of the servers store exactly the same content, so the content is duplicated. We still have a player, and it works almost the same. The player measures the bandwidth with each of the individual servers continuously. It sums the bandwidth, and then at the end of these sums, it selects the next quality, the next segment quality. But instead of retrieving the segment from one server only, it retrieves the segment concurrently from all available servers. In this example, we have 3 servers. So the content is retrieved partly from the left server, partly from the middle, partly from the right server, right? And the contribution of each server is according to the measured bandwidth. For doing that, for implementing that, the player used the HTTP byte range facility. So it's a cool technology. It inherits from all benefits, from the benefits that we already saw with simple monopath HTTP adaptive streaming. But in addition, you inherently provide a bandwidth increase. And even if you have exactly the same bandwidth budget, it mitigates congestion, right? So the condition here is that you need to have paths as orthogonal as possible. This is really the strict and very important condition. As long as you have this orthogonality of the paths, you mitigate congestion, you increase the throughput, and ultimately you reduce the QE variation. You smooth the QE, which is very important from the user perspective. Overall, you have less buffering, so you reduce the latency. And implementation speaking, you don't need extra particular features on the server side. You just need to duplicate the content like we are doing in CDN, right? Very important side effect. Inherently, you provide a load balancing solution. And a failover solution, of course. So where does it come from, this technology? We started to talk about multipath streaming around 2004, 2005, when most of the streaming solutions were based on UDP at that period. The problem with streaming over UDPs, the guys solution experimented a lot of packet losses. So they had fake, but the server didn't control anything about the bandwidth, so that was terrible. And one guy and one team had the idea of operating several sender and one receiver that could compute the bandwidth with all the receivers, with all the senders, and try to orchestrate the senders in order to send part of the content. So that was the beginning. A team called published in 2007, I guess, the first paper about streaming over TCP. And streaming over TCP using multipath technology. So that was a very important paper. I recommend you to read that. This was the basis of this of the work and of the HTTP multipath adaptive streaming. So the idea was to stream from two orthogonal paths again. They focus, in order to compare the solution, monopath solution versus multipath solutions, they focus on late packets. So packet is late. If a packet is late, it cannot be used for video rendering. That was the idea. So basically, they had 3 lessons from this, which was very fundamental for TCP streaming. First, you need, for live streaming, you need an aggregate achievable throughput at least equal to 2 times the video bitrate. You can increase the live streaming throughput. So using multipath, you increase the live streaming throughput. Basically, if you take the video bitrate that you can play on each individual path, if you use the same path in a multiple path ways, then you get a gain in terms of throughput. And the last lesson, the last result that was very interesting is that if the paths are unbalanced, I mean with different RTT or different loss rates, it is not impactful. That was great. That was why in 2008, 2009, a team worked out, based on the work I just presented, worked out this multipath HTTP adaptive streaming. They just applied the one and all mechanisms and principles to HTTP adaptive streaming. So I recommend you to go and read these documents. I know very well this work because I belonged to that team at that period. And again, that was the same idea. We compared the solutions, multipath solutions versus monopath solutions by counting the number of late packets, counting also the different qualities that we were receiving on the player side. So we did a lot of measurements in the lab, we play with the latency, we play with the packet error, with the burst packet loss, and with the delay, with a lot of criteria, with a lot of parameters. We also conducted real experiments. At the end of the day, we found this technology very promising. Okay, so how can we implement this kind of solutions? There are basically 2 ways to implement it. The first one is to integrate the management of this multiple path in the player itself. This is what we did in the lab, but it's not very useful for deploying quickly such kind of solutions. So the other way is to implement it as a proxy server. So it's collocated with the player, but this is almost transparent for the player. It doesn't know there is a proxy behind that will go and manage this multiple path activity. So proxy server is a solution that we try to work out and then try to better understand. So the problem with the proxy server is that you don't want to add latency, right? So you have to be very careful not to add latency. So the way it works, here you have 3 paths. we submit concurrently the request, asking each of the server, requesting each of the servers to contribute according to its bandwidth. So the green path is the fastest path. The purple one is the second fastest, and the slowest is the red path. And each of the servers starts contributing, sending the bytes, sending the packets. And on the green side, as soon as we receive the green packets, we just forward these packets to the player. But for the other colors, we just store them and wait the end of the green delivery, right? At the end of the delivery, as soon as we got all the packets from the purple and red side, we can send everything as a bulk transfer. So in other words, we don't introduce any latency in these mechanisms. But there are some drawbacks here because we detected that some players do some measurements. The player has to do measurements to understand, to evaluate the available bandwidth. So the player may be misled here because when we send the rest of the data, the purple and the red ones, it may detect a bulk transfer. So it could believe that there is a lot of bandwidth, although there is not a lot of bandwidth. So then we developed what we call an Intelif Mod. So the Intelif Mod is used to compensate the bandwidth evaluation problem I just described. It's also used to evaluate the segment size because in the manifest, we have an idea of the duration of the segment, but we don't have any notion of how much bytes, are in this segment. So we need to evaluate and estimate it. And the solution consists in splitting the segment in artificial chunks. Again, notion of chunk. But these are not the same than the chunk transfer encoding, as this is very different. Well, there is a relation anyway, but I will describe later. So we split the segment in chunks, and then we distribute the retrieving of each chunk among all the servers. In that way to do, we can ask the contribution of each servers. We can distribute this contribution along all the time we need to get the segment. I don't know if I'm clear. It's quite complex to explain, but it's just to give you an idea, the sense of what we did for having this technology really worked in a product. And there is the low latency now. This is some ongoing work. This is not yet ready, but you can see that intuitively, this notion of chunk, looks very close to the notion of HTTP CTU, and this is something that we are working now in order to have these solutions compliant with the chunk transfer encoding, HTTP chunk transfer encoding, CMAF, low latency. So how can we deploy this technology? So we can have the obvious way to deploy it is to have one server per CDN and just having our server proxy in the terminal collocated with the player. Another one is that a CDN, or let's say a CDN provider may decide to implement itself this technology by, indicating the number of servers or the location of the server that can contribute to the multiple path. Another one is also to give orthogonal path, really physical orthogonal path, right from the beginning by, operating physical interfaces like LTE, for example, plus Wi-Fi ADSL or Wi-Fi cable. So now that we've got an overview of the technology, how can it be used to enhance the delivery solution from the content provider perspective, from a broadcaster perspective? So let's start with the delivery chain, right? From the content, again, from a content provider perspective. So what does a content provider needs to do for controlling the QoE of its delivery solution? First, you need to host the origin packager, right? Because this is where we decide about the quality later. This is very important to host the packager, the origin server. Second, it has to use a technology called CDN selector that is broadly, used today. It's a way to, to switch from one CDN to another CDN, depending on many criteria like you are aware of. Now, here we have our multipath agent in the end user terminal. So this way to do, we don't have to do the selection, it's kind of automatic selection. It will be managed automatically according to the measure and the available bandwidth. Automatically, the load will be, on the balance on the side where the bandwidth is available. This is, let's call it an automatic switch. The last way to operate for the content provider perspective, instead of operating directly CDN service, it can also decide to operate local cache. So what we just talked about edge caching, right? This is the idea. This kind of box, a local cache, is a kind of, like Netflix is operating, right? An OK server. A server that resides on the NSP network, and the content provider could operate directly. So this is a great solution, and this can be deployed, progressively. Content provider can deploy it progressively. But by deploying this solution progressively, you may want to mitigate problem. You can face overloading problem. You can face failover problems. So instead of, trying to deploy directly and immediately a big infrastructure, you can just rely on this multipath agent again, and therefore, using these mechanisms, you can deploy progressively your own infrastructure and, compensating the good setup with the multipath agent. Okay, so I just described two things. I described you multipath HTTP adaptive streaming. That is, again, a technology that provides automatic load balancing, automatic failover, and that use concurrently multiple paths operating multiple servers. And I also show you how we can combine this technology, this multiple path HTTP adaptive streaming, with CDN features in order to provide to the content provider a way to really control its QoE. Thank you.
So before I start, any questions from the floor? Yes, Eric, you'll have to run.
You didn't talk about the efficiency. What sort of efficiency can you achieve with this method? I mean, what sort of overhead do what sort of cost overhead do you incur because of this approach?
Yeah, efficiency. So that's why I mentioned the papers at the beginning that described, it's a full set of measurements that describe you how efficient is a solution like that. It's difficult to give you. I could say I could give you a percentage, right? But I recommend you, frankly, to read the paper. Basically, what it does, it's operating a good diversity. That means, again, your path needs to be as orthogonal as possible. So you should avoid, shared segments as much as possible. Depending on the multiple paths that you provide, the overall, the benefit of this is maybe, I could say 20%. Basically, you smooth the quality of experience. I prefer to say that instead of giving you numbers. Of course, I can give you numbers. If you don't have bandwidth constraint from the server side, you can immediately operate the gain of bandwidth provided by all the multiple paths together, right? So I don't need to give number. This is obvious. But there are plenty of contexts. So the benefits where the benefit is obvious. Difficult to give numbers. You have to look on the paper.
Any more questions from the floor? Yeah. All right.
Guillaume, salut.
Bonjour.
So my question is really along the same line. So it seems like you're saying this multi-path, adaptive streaming is actually provision of some redundancy, right, on multiple paths, right? So you are using multiple paths to transmit the same signal to an endpoint. And so one thing that is obvious is that you are going to need more bandwidth right? So, and it would be nice if you can, or if you have quantified the implication of that. I don't know whether that's contained in the paper you mentioned, but obviously you need more bandwidth to make this work. So instead of transmitting X megabit per second on a single path, you are going to transmit it on multiple 3 paths, so it's multiplicative, or additive. So that extra bandwidth might end up being the cost of achieving that improved QoE you are talking about, right?
The way it's a bit linked with the previous question.
Yeah, that's what I'm saying.
You have to think about a constant budget, bandwidth budget. So instead of saying, with this technology, you're going to get more bandwidth, let's say it differently. For the same bandwidth budget, so let's consider you have a CDN, content delivery solutions. You don't have more bandwidth, but you operate and you are more efficient in reusing the bandwidth. Basically, as I said, you have more throughput by operating multiple paths with these solutions than operating each path individually. You have a gain in terms of throughput because you distribute the problems along the path, right? This is exactly that, right? So then the throughput is maybe 10 to 20% you increase with the same bandwidth budget. This is what you have to remember.
Okay, Guillaume, I have just one question. Some elements of this look rather similar to what I call cell muxing or link aggregation, where cellular portable video encoders increasingly have technology embedded which allows you to send a signal over multiple paths, over multiple cellular links, and then aggregate that back together using, I don't know, link aggregation at the core of the network, and then forward it all as a consolidated pipe. I'm trying to work out if they're just parallel technologies or actually if they're very similar.
No, I'm not sure what you mean by cellular. I think there is this notion of antenna diversity, where this is basically the same idea. In radio diversity, what we are doing is we're just sending the signal, through separate radio paths, and the receiver side we are capable of aggregating these paths, and at the best we can, increase the reception power, but just by doing that. So it's a bit the same idea, right? Yeah. This is a bit the same idea. Otherwise, in the cellular, we don't duplicate the data, right? We don't do that. Yes, by the way, I didn't took the time to explain more, but there is a particular use case, and we just talked about it a few minutes ago. It's the cellular, the mobile network. This is also I didn't depict different use cases for the edge, but think about this, where you have an edge, where you want caching on the edge for a mobile network. So that's the solution also that helps to do that, because you're moving continuously. You don't know whether you will have a cache at the edge. You might have cache, but you might not have it, because the edge data center is something that will be shared, by many different solutions, and dynamically you might end up with having no cache for that time. So by doing these multiple path solutions, where you rely not only on one edge cache but on several edge caches, you mitigate and compensate these kind of problems too.
Perfect. Okay, merci bien, Guillaume. Thank you very much. A round of applause, please.